Hello, everybody. Welcome, welcome, welcome. And I'm going to get started here in a second. Sorry, I just had to run upstairs for a sec. Okay, I'm going to start today's meeting, and I am recording it, just so you guys know. And I'm going to share my screen, as I do with most meetings. And what I want to do is go to our 40th page and start with our agenda for this week. This week's agenda, which I will record and post after this class, is to complete the advanced classes example. There's only a little bit left to do from last week, and then I'm going to do a walkthrough, completely going through the actual problem for the advanced classes unit, the one programming problem. And you feel free to jump in and ask questions, but I'm going to go pretty quickly. You can always go back and rewatch the video if you want to do that assessment and complete that unit on complete the unit on advanced classes. Now, of course, as you know, your mark is already locked in. So completing this work to continue your learning is mostly intrinsic in nature. It's not really a direct representation of how it's going to affect your mark. But that's the agenda for today. I've also updated what the agenda kind of will be for each week from here on in. Okay, so you can see here, I want to go over the collections example in the next couple weeks, every Wednesday at 1 o'clock. Okay, and then all the way up to the end of the school year, some advice on how to complete a final project will obviously be coming up as we move forward in this course. So that's all the what the online classes will be. Where we are right now is in our example, we got to about here or here. We last week created the meeting class, created the food, and created a whole bunch of classes to sort of show those interconnections. If you look at our advanced classes package now, there's a whole bunch of classes in here. Last week we added banana and the computer science teacher and the doctor and the donut and the food. Okay, food, which is an interface. You can notice a slightly different icon there for food. Football, which is an interface. The high school student, the hockey. We added a bunch of classes. Today's agenda is to continue where we left off with that. And actually where we left off was we had created this class called the Husky Athlete. And the Husky Athlete is an interesting class. It is a Husky, so it extends the Husky class, which extends other classes. Okay, everybody, it was at this point in the video today that I noticed later that the video had stopped. And at first I thought there was something wrong with Microsoft Teams, and then later I realized that the problem was that when I looked in the stream, which is what Microsoft calls it, that some of you had actually tried to record the video yourselves. And I guess what that did was it stopped my recording and put the video into your recording. So after the fact, I was able to recover a little bit from the front, and then I grabbed from one of your streams a little bit from the back, but a big part of the middle of the video is missing. So I'm re-recording that right now. Okay, so what I want to do right now is just to sort of pick up where the video had left off, which was creating the Husky Athlete. So what we did was we then created these 4 private properties of the Husky Athlete class to store whether or not they've signed their permission form, the name of the opponent, our score, and our opponent's score. Because the Husky Athlete implements these interfaces, we also were forced to write some of the methods of those interfaces. So for example, we wrote the sign method, which you can see right here, which signs the permission form and does an output. We wrote the have you got it signed, which returns whether or not we've got it signed. We wrote the goal method for hockey, which checks to see who got the goal by their name. So checks that parameter and then either increases our score or our opponent's score and outputs that our opponent got a goal or that we got a goal. And then our end of period method for hockey, which fills up a text variable with information about the period and the score and our name and our opponent's score and our opponent's name, and then outputs that variable. we did the setOpponent method, which is a mutator method which takes the name parameter and changes it and sets the private property of the class to that parameter. We wrote a didIWin method, which checks our score versus our opponent's score and returns either true or false, and either says that we won or our opponent won. We wrote a score method for football, which has two parameters, checks the name like the hockey method, and adds the parameter points to that score either for us or our opponent, and does an output just like the hockey score method. And like the hockey end of period method, the end of quarter method also fills a string variable and then outputs it with the same sort of information about the quarter and scores and things like that. And we're able to do that and then run a test on that by creating an athlete. 17 is a male student number, having that athlete talk, running 4 rounds. The first round, they have not got it signed, so then it signs it. The next round, it sets an opponent, scores a couple of football points, scores a few hockey points, some for us, some from our opponent, ends the period and ends the quarter. And then finally, if the athlete won, the athlete had dinner using a food object donut. This is a method we had written in the previous video. Okay, once we'd finished that and tested that, we then went on to create 4 basic primitive data types: Boolean, integer, double, and character. And then from those 4 basic data types, created wrapper classes with the capital letter here, and using special constructors of those wrapper classes to assign the primitive data type to a more sort of wrapper type of Boolean, integer, double, and character. We also did string, which string already does this. String is already not a primitive data type. And although you don't have to use this constructor for the string class, we did. Then we wanted to output all these different data types using one method, which we then wrote, which is called a generic method. Generic, and we talked about the special notation on how generics are used and how this stands as a placeholder for this data type of that item. Filled up a string variable with various information about the item, including the class name and what it looks like calling upon the toString method, and then outputting that item. And again, I remind everyone that generics is definitely something you like a lot in this unit that you want to read about or watch the video or look at the GitHub or look at the review. So you should definitely look at, for example, the various videos I've created for this unit, or read through the PowerPoint, for example, about what generics are. Relook at the GitHub code, which I'm working on now, obviously. Even looking at the unit review, where it covers these content in more detail. Okay, once we'd finished looking at this generic method, we made what's called a generic class, and the class was called box. A box that can hold anything, a data type of anything. So we're using a generic as a stand-in, as a placeholder for what that data type will be. The box will hold a present, the constructor for this class passes that present and assigns the parameter to the property, and then 2 simple little methods, one to open, which returns the present of data type undetermined, and a peek method, which just uses an output and calls upon the toString method. And we were able to use that in our testing class to create a series of box items. A box that can hold Booleans or integers or doubles or strings or even Husky athletes. So the data type is generically placed there at the time you define the class, and then when you use the class, when we create an instance of the class, that's when you actually define the data type. So the various ones we'd created are then used within the boxes, and then we can peek in all those boxes. And then after we've peeked in all the boxes, I opened all the boxes, which returned the data type. So I actually ended up assigning it to a brand new data type because it returned it, and then outputted all those brand new data types to see if they were the same. And let's do a run of this code. You can see it did work, right? It did exactly as we expected it to do. Finally, what we did in the example today was we then went and created a class called the house class, which also used a generic data type, but this is what's called a limited generic because it is saying it can be anything as long as it's of type person or any children of the person class. And then we also showed how you can actually have multiple generics. So the other generic, I just used the letter U, which is just alphabetically the next letter in the alphabet. T represents the owner of the home, which is of any type person, and U represents the contents of the house, which I've not limited that generic, so that can be any generic item. We then finally wrote a method called party, which is a generic method that uses a third generic data type, V, which is limited to just food. And then we have an array of V items. We output the homeowner's name. GetName is a method within the person class, so it was able to do that. We outputted the contents. ToString is a method in all objects, so we knew that was in there. We used an enhanced for loop to loop through every item in the array of items and called the have dinner method, which is built into the homeowner because the homeowner is a person. And item is of type food or a child of food, so it was able to pass that along as a parameter. In our testing class, we were able to create a house, Sturgeon Heights, the owner, Mr. Walks, and the item in the house is a husky item. So then we assign those. The Mr. Walks and the athlete is the husky that was put in there. Okay. And then we created an array of food objects called a fridge with a banana and a donut. And then we were able to party with that fridge. And yes, when we ran it, that code worked as we would have expected it to. And the outputs were exactly the way we expected them to be. Okay. It was at this point in the video that I think then I went over the various pieces of the advanced classes assessment. So I'm just going to show those again. This video does pick up, and I'll connect that video to this one where all that went through. So this class and the pet class, or the pet interface, the order class and its various methods, slowly scrolling through those. The sale class and its various methods. And the dog class and its various methods. And the poodle class and its various methods. And yes, we were able to run that and make sure that worked as well. At this point, I'm going to stop this video as then the next video picks up from. All right. And then what you're going to do with this is just follow along. Okay. These will be the 2 lines in main. Poodle Fluffy, Poodle Scooby. I'm going to get to those later. I'm going to jump to the second one. I'm going to create a pet interface. All right. Scrap comments. It's pretty simple. Okay, so advanced classes assessment. Right click, new Java interface called pet. All right, here's the pet interface. What do I know about this pet interface? Okay, so it has a series of abstract methods defined within it. So let's take care of those. Okay, so the pet interface has a void set name, string name, method signature. It has a string get name, method signature, and a void sold method signature. It's an interface, so I don't put any code to these things. And that's what you would see if you read right here. That's the method. It tells you a little bit about parameters. So you have to kind of interpret what I've said here into this. And now we're going to make an abstract class called order to move on with this. Okay, so there's the interface. Next up, a new Java class, order. Okay, order would represent selling stuff. Okay, so I'm going to scrap all these pre-made methods, which are fine, but for purpose of time, I'm just going to shrink down here a little bit. Okay, so order is an abstract class, which means it can't be instantiated. Okay, it needs a protected thing we learned in this unit, integer called the order number. Extra letters. Order. There we go. It needs a constructor. When you make an order, here is the order number and the code. This dot order number equals order number will apply. It has an abstract method, public abstract void set price. A double for that price. As an abstract method, it has no content to it. It's just like that. It has a second public abstract method, a double get price. So we have accessor and mutator methods as abstract method signatures here. And you can see that in the way I wrote it right here. Abstract method, double, abstract method returns a double, order number, a property that's a protected integer. So that's all kind of laid out in the instructions there. And that would represent our order class. Right click, new Java class. The next thing we're going to create, as it outlines right here after order, is a class sale, which uses generics. All right, so we'll make a sale class. I'm going to trash some of the inside code for now, keeping it simple. Zooming in. Sale, the class, uses a generic data type. Okay, it's private. It's of data type T. It's the item we're going to be selling, the sale item. Okay. It also stores a price for that item that's going to be sold. Both of these are private properties of this class. It has a constructor. Constructor takes both of these items as parameters, sale item and price, and it assigns them. There we go. Okay. Or the other thing is a sale is a order. So we're having one class extend the other one. So since that's the case, okay, I don't really need the price here as a parameter. Instead, what I'm going to have is the order number. And then I don't need this line. Okay. Instead, what I do is I go to the superclass with that order number. So it goes to the order here and it pulls that in that way. Okay. And since sale now extends order, okay, it will need to implement the abstract methods, which means set price, this dot price equals price is done, and get price, return super dot get price. Okay. What do we got going on here? Abstract cannot be a return price. There we go. Which comes from the order class. Well, sorry, which is in this class. Anyways, there we go. There is the sale class. You can kind of see all the code there. And again, following this would be right here where it goes through each of the sort of instructions on that. All right, now moving on. We're going to now create a dog class, new Java class called dog. And as you would have probably guessed, a dog is a pet. So it's going to use our interface that we created at the beginning. It's going to implement the pet class. So the dog follows the rules of pets, which means it's going to implement the abstract methods setName and getName for this. Okay, so the dog has a property, a private string name, the name of this pet. So right here, this dot name equals name. So the parameter is assigned to that private property. GetName returns the name. Okay. There we go. The other thing I'm going to do with this is, in addition to these, I'm going to write a method for this dog class, its own special method, public void sell. How do I sell a dog? Well, to sell it, I need to know the price of that dog. I'm going to need to know the order number for that dog that I'm selling. Okay, let me shrink this down a little bit. So I'm selling this dog, which means I'm going to add another property to this class, a private sale item, since I'm selling the dog. And again, this is all outlined in the instructions here, a sale property, which is private. Okay, so now that I'm selling it, my sale equals a new sale, and sale requires the item. This thing is the thing I'm selling, and the order number. I'm selling this dog. And then the other thing is that sale, I have to set the price of that dog that I'm selling, which I just did. Okay, so now that dog can be sold in that way, but I still have one more method right here to write. How do I sell what happens when a dog is sold? Well, what I'm going to do is just output, and I'm going to change print line to just print, not print line. And I'm going to say order attached to that sale dot. I'm going to get the order number. Wait, do we have that method? We might have forgot that method. That should have been in the sale class. Let's go back a step. Yeah, I forgot to put that one in there. So in addition to the sale, I did outline that you would make a public int get order number. It's an accessor method, so it's pretty simple. It just returns the order number. And that's so that we can keep the order number within the sale object, okay, the order number itself, which comes from the superclass. The order number comes from the order, which is right here, and it's protected. That's kind of some of the reasons why we've been doing all that. So now I can get the order number when I sell my dog. And let's go back to there. And then a space, so order number this. And then I'm going to have my dog's name. And then I'm going to say is worth. And then I'm going to have the price. And I get the price that I sell it at. Okay, so that's my dog sold method. So it says order, gets the order number, the name of the dog is worth, and gets the price. Final class we're going to create is a class called Poodle. And you can probably guess that a poodle is a dog. Revolutionizing anything there. But here we go. Poodle extends dog. There we go. So as a poodle is a dog, now I would read the instructions on what it is to make a poodle. So there's some properties here and some methods here, and then we're almost at the end here. So let's take care of Poodle. So Poodle requires a private static integer called poodles sold. So that's a shared variable that keeps track of all the poodles sold. It also has a private final integer for the price of a poodle. And I'm going to make the price of this poodle $99.99. Okay. Whoops, that should be a double. There we go. All right. Then I'm going to make a Poodle constructor. Public Poodle. When I make a Poodle, I will give it a name for the Poodle, and an order number. The order number of this particular Poodle as I construct it and sell it. So first thing, the Poodle sold now goes up by 1. I've sold 1 more Poodle. Okay. I will set the name of this Poodle, which to access, I go into the superclass and use the mutator method to set the name. I will sell this Poodle at this price for this order number. And then finally, I will call upon a sold method. Now that means the Poodle will be sold. Now I already have this method. It's in the dog class, so it would already call it. But I'm going to override that method with my own version of sold. The final method here. So this method will override the other one in the parent class dog, but I can still call upon it. So super.sold. So I'm calling upon the previous sold method and then doing another output, and we have sold that many Poodles. So I can use the static variable to indicate exactly how many Poodles I've sold. That would conclude the final piece of this, of me finishing up the Poodle class. And now I can go back to my main method and add these 2 lines in there. Poodle Fluffy, Poodle Scooby. So let's go all the way back to main right here. And let's create a Poodle Fluffy equals a new Poodle. The name of that Poodle, Fluffy Pants. And order number, what did I say there? 101. And then a Poodle Scooby. A new Poodle Scooby-Doo. Number 102. And when I run this now, it's going to build the Fluffy object and then build the Scooby object. Go to the Poodle class, run the constructor, set all these things, call upon a sold method, which will do an output. And let's see if the output, I'm going to run that, matches what it says it should be right here. Order, like it tells you exactly what the output should look like. So let's see how that looks. And there it is, the exact output we're looking for right there. Okay. So this is a combination of a ton of stuff in this unit again, all coming together here. You can see interfaces and multiple classes and abstract methods and generics and all kinds of stuff coming together in the various pieces of code. It's not a ton of code, like you can see here. The dog class has got, a few lines of code. The sale class, lines of code. The order class, even less code. The pet interface, very little code at all. So all of that code started coming together to eventually get to this Poodle class, then eventually get to main to run that, and that's it. That's this giant unit called advanced classes, the largest unit of the of this 40S course. So that's it, guys. I'm going to turn this off now, this recording. If you guys have any questions, you can answer them. Did I not? Oh yeah, I did record. So in a second, I'm going to turn the recording off. And then if you guys have any questions, feel free to ask them. But if not, I'll see you guys next week. I will put all the comments into this and then put it up on GitHub as well. I won't be putting, obviously, this up on GitHub, but you can go back and rewatch this video. You can't see what I'm doing. Let me share my screen again. I won't be putting this up onto GitHub. This is the actual assignment. But you can go back through this video, and I'm just going to slowly show right now each of these classes. So you could pause the video and take a look at the code for each one of these to get a feel for exactly what you need to do to complete those assessments, that assessment, the one assessment for this unit. Okay, there's dog. Oh, that's a little small. And there's Poodle. Okay, all right, everybody. I'll stay on the line for a second, but I'm going to turn off the video. I'll see you guys next week.